Okay, so the first applications, like the random applications that I can name are basically firstly the applications of planes to find out to find angle between them angle between them. The second is the what we say is basically intersection of a line and a plane. The third concept here that we have is the uh, check if check if planes are check if planes are perpendicular, parallel, and so on. So these are the IB strategic questions that they give. The fourth key concept that they give is to find out angle between a line and the plane. So what we are going to try to do is that we're going to cover up this part. Of course, then we have last one is the intersection of the plane, intersection of planes. So in this segment, what we're going to first do is I'm going to cover up till here, and there'll be separate a lesson on how to find out the intersection of the planes. So now let me just begin with the first part, which is finding the angle between two planes. How do we calculate the angle between two given planes? So here's a very simple way to remember that. So angle between two planes is same as angle between same as angle between their normals. So when you find out angle, if suppose let's say the equation of this plane is 2x plus y minus z equals to 8 and x plus y plus 3z equals to 5. So when you want to find out the angle between these two planes, you're going to first take the normal to the first plane, which is 2, 1, negative 1. And the normal to the second plane is 1, 1, and 3. And so when you're finding this angle, actually, let's say this or this angle, whichever angle you'll get. So if you get the obtuse one, it is this. If you get the acute one, it is this. It is going to be same as this angle. So as far as the angle between two planes is concerned, now you have to just take the dot product and the normal procedure to find angle. So in this case, it'll be cos theta equals to dot product of these two, which is 2 times 1, which is 2, plus 1 times 1, which is 1, minus 1 times 3, which is negative 3, over, then what we get is magnitude of the vectors, which is square root of 6 here, and here it'll be square root of 11. Now, as we clearly see that numerator cos theta is becoming 0 because the numerator is 0, I can clearly conclude that these two planes are perpendicular. So these two planes are actually, one plane is like this, the other is creating like a right angle, or something like this here, if I can show. So this is a simple context that these two planes are perpendicular. Now, as far as the uh, second part is concerned, so let's say here is an example, and one more example. In case if I wanted to find out the acute angle between these two planes, so the angle that I'm getting is, let's say, first you take the normal, which is 2, negative 3, and 4, and the normal to the second is negative 1, negative 2, and 4, and then you're going to find out the cos theta. So cos theta of the normals n1 dot n2 upon magnitude of n1 and magnitude of n2. So this is how you find out the angle between the two planes. What is very interesting is that if I wanted to check if two planes are perpendicular, so if two planes are perpendicular, as we just saw, n1 dot n2 is 0. Simple, as simple as that. If two planes are perpendicular, so sometimes if they're giving, let's say ax plus by plus cz equals to, let's say, I'll give, let's say, some knowns and some unknowns. So let's say here is ax plus 8y plus 2z equals to 5. And I have been given x minus y plus z equals to 3. If two of these planes are perpendicular, let's say you get to calculate the value of a. So how do we do that? So in this case, as we know that the normal to the first plane is a 8 and 2, and normal to the second plane is 1, minus 1 and 1, which is simply the coefficient of xyz. Now the dot product of these two will be a minus 8 plus 2 equals to 0. So that gives me a as straight away 6. So this is how you find out the case where, find out the missing values in the case where two planes are parallel, perpendicular. Now the interesting point is that how do we know that where two planes are basically like the perpendiculars, I mean the parallel. So in that case, if two planes are parallel, now you can simply see that suppose if it is they are parallel planes, I draw the normal, the one normal acts like the normal to the other as well. So in short, what I can say is that if one plane is perpendicular, parallel to the other one, then what is going to happen is that, let's say A1, A2, and A3, if it is the normal to the first plane, B1, B2, B3 is the normal to the second plane, then what might happen is that B1 upon A1, B2 upon A2, and B3 upon A3. This has to be the same, because if N1 is and N1 and N2, if N1 and N2 they are parallel, if they are multiple, if they are scalar multiples, then we can say that the two planes that we are talking about is they are parallel. So that's how you kind of deal or tackle with the situations in the case where the planes are parallel and perpendicular. Now, coming back to the second application. So here are the summary that I just discussed. So if the two planes are perpendicular, the dot product of the two normals is 0. If they are parallel in space, then N1 and N2, they are multiples. So let's just take an example where this is been given. So here is the example that 3k minus 4y plus 4z equals to 10, y minus z equals to 3. If these two planes are perpendicular, you have to find out whether find the missing value of k. So as they are perpendicular, the dot product will be 0. So I get k as negative 4. So that's how we do it. So this is the basic key concepts that is linked with the parallel and perpendicular planes. Now, next up is the application of lines to lines on the planes, which basically is very interesting since it is assessed in almost every IB exam. So when we simply look at the context here, the question that they'll ask you is that they'll find out the angle between a plane and a line. So if I can show it to you, so suppose my plane is here like this. This is the plane that has been given to you. So this is the plane and the red one is the line. Now, when they're asking you to find out the angle between the planes, so they're asking you to find this particular angle. So this is the angle that I'm asked. So what I'm going to simply put is a question here that is there a way you can think of that I can find out this angle? Now, obviously, I have done several times the same thing here. So you can see that this particular part, if I can find out, and since I know this is the normal, so this will be right angle, and I can subtract this angle, which is from 90 to get this. So that's the procedure to find out angle between a plane and a line. So in short, what I did is a plane is here. A line is intersecting something like this here. Let's say passes through the plane. And I am finding out this angle first, and then I'm calculating this particular angle. So very interesting question is how do we do that? So in case, obviously they will give you the equation of line. So equation of line is given to you as 215, and equation of normal you got to find out, which is 2 minus 1 and 3, which is minus 1 and negative 3. And then you do the same stuff, which is cos theta is the dot product of normal with direction of the line. So we are trying to find out this angle basically first, and then you take the magnitude. So if you take the magnitude of the line and normal directions and divide it, you're going to get this angle. So what you're getting is simply 107.02. So 107.02 is this angle. So obviously you have to find acute angles. So it'll be, let's say, 180 minus that. So that you get here 72.98. And if you do 90 minus 72.98, you get this. So in short, First, you find angle between normal and the line, and then you subtract that angle from here. So this is how you find out the angle between the line and the plane, given the given intersecting plane. Now, here is a simple example, one more example for hands-on practice. If I have been asked to find out angle between r equals to t 111 and r dot n equals to a dot n. So this is sometimes they give you this form as well. So this is your line and this is the plane. So they don't give in the question that, okay, this is line and this is the plane. You got to figure that out. So, okay, so r, if I have the first one is 111 is the direction of the line. The direction of normal is 156. You're going to do the cos theta normal dot product, which is here. I have done it. And you get the angle between the line and the plane. First angle between the line and the normal, and then subtract from 90 to get the given angle of the line with the plane. The last up is basically summarizing when a line and a plane are perpendicular, when a line and plane are parallel. So it is a very simple observation that if I say that line is parallel to the plane, you can see that straight away the normal and the direction of the line, they create a right angle. So if I take the direction of normal and take the dot product with the direction of line and it's coming to 0, then we simply say that the line and the planes are parallel. Now, very interesting question that I also see here is that when the line and plane are parallel, so when the perpendicular, so when the line is perpendicular to the normal, which is, the plane, in that case, the direction of normal and direction of the line is the same. So again, here, the case is if we get A1 and let's say if you get B1, if you get B1 and let's say you get B2, N1 as the direction of normal and this thing, they will be scalar multiple. So n will be multiple of b and vice versa. So this is how you kind of understand the basic key concepts of normal and the angle between two lines and angle between two planes. So angle between two planes, angle between a line and a plane, and the basic key concepts about when they are perpendicular and parallel. And the last key concept that is remaining here is how do we find out the intersection of line and a plane? So I'll try to be quick here. Now, in first case is that I have to find out this point basically. So they're asking you intersection of line and a plane. So when a line is not in the plane, obviously when the line is in the plane completely, then this will be having infinite solution. But when this is not in the plane, you have some strategy to do that. You have to follow certain strategy. Now, for example, here they give you the equation of plane and equation of line, and they ask you to find out this intersection. So first thing what I'm going to do is I'm going to find out this particular position vector of this point in terms of s, because that point lies on the line. So the position vector of that will be, let's say, coordinate, if I take it as t, so its position vector will be -3 plus 2s, 1 plus s, and 5s. Now, what is really interesting is that if you see this is the intersection point, and this point also lies within this plane. So if I put x as this, I put y as this, and I put z as this, I get the value for s. So once I get the value, and you solve for the equation, and once you get the value for s, you plug out here or in this equation here to get in this position vector here to get the exact coordinate. Let's have a clear solution of this. Let's have a look at this one. So, so first convert the line in the parametric form. As you know, the parametric form is the general coordinate of any point on that line. And then what happens is that you input this coordinate for x, y, z out here. And once you solve that equation, you get the exact s value. So the exact s value that I'm getting here is, let's say, 9/16. Now then you plug in the x coordinate, which is like here s value if you plug here, s value if you plug here, s value here. So you get the exact dot point, the exact coordinates of the point in the where the line and the plane intersect. So this is this short application of the lines, planes, intersections, angle between lines and the planes. And in case if you're not clear, you can watch this video again, and I hope this is helpful.